Okay, in this question, this is Spring 2006 question 4A, and it's actually an integration question. It's an integration of an area. What we're asked to do is find out the area enclosed by the line y equals x minus 5. That's this straight line going up here. And the curve y equals x squared minus 6x plus 5. So essentially what we have to do is find out the area of this green area here. Okay. Now I'm not too worried about intercepts of x-intercepts and y-intercepts. But essentially we have to find out the area of this green area here. Now it's a definite integral, but what we have to do is find out first off where the points the lines intersect, and really we only need to find out the x values. So we don't really need to know the heights, but we do need to know the x. We don't need to know really the y values, but we need to know these lines here. So that's one intercept point, and that's the vertical line that goes through the intercept point. This is the other one over here. Move that there. So we need to know what this point here A is and this point here B is, or this line. Okay, I'll just move that back into focus. So what we're going to do here is use simultaneous equations to find out the values of A and B. Essentially where the x values of both of the intercept points. So let's go to a new page. So equation 1 is y equals x minus 5, and equation 2 is y equals x squared minus 6x plus 5. What we're going to do is let them equal each other. X minus 5 equals x squared minus 6x plus 5. Okay, that is, if you sort of solve that, what you would get is x squared minus 7x plus 10 equals 0. So what we have to do here is factorize this expression here, and that should be quick enough. So that is x minus 5 and x minus 2 equals 0. So x is either equal to 2 or 5. So let's go back here. This here is the line x equals 2. This is the line x equals 5. Now, that's important because that's our definite integrals, okay? So, what we're going to do now is just a sort of remark that this is the top part, this is the upper bound, and this expression here is the lower bound of the curve. So this is the top limit of the shaded area. The top limit is y equals x minus 5. It's below that line x minus 5, and it's also the bottom limit is y equals x squared minus 6x plus 5, so it's above that. That's important. So essentially the area we're looking for is as follows. So the area is the integral, and put in our limits there, from 2 to 5 of x minus 5 minus, that's the upper limit, minus x squared minus 6x plus 5 dx. Okay. Let's simplify that. That is 5 to, that is minus x squared. Sorry, I just got my notes in front of me. Let's bring them up. Plus 7x minus 10 dx. Okay, if you just sort of work that out. Now, integrating that, we will get minus x cubed over 3 plus 7x squared over 2 minus 10x, okay, plus c. So, without evaluating the definite integral, that is our answer so far. Okay. Now, so let's evaluate the definite integral. So we have this part here done. That's the main part done. Now all we have to do is evaluate it. And let's do that. So minus x cubed over 3 plus 7x squared over 2 minus 10x. This is the definite integral, and evaluated from x equals 5 to x, or x from x equals 2 to x equals 5. So for that, let's evaluate it for 5 first off. So minus 5 cubed, that's minus 125 over 3, plus 7 times x squared, that's 7 times 25, that's 175 all over 2. Minus 10 times x, that's minus 10 times 5, that's minus 50. Okay. And now let's evaluate it for 2. So that's minus x cubed over 3, that's minus 8 over 3. 2 squared over 2 is 7 times 2 squared is 28 over 2. That's 14. Sorry, let's put that back. That just plus 14 is 28 over 2. And minus 10x is minus 20. Okay. Now this is actually just a bit of number crunching here. You can sort of break it down a bit, but essentially the answer will work out to, I'm going to break it up into two parts, minus 25 over 6 plus 26 over 3. That's just me doing a few simple notes. I'm going to sort of skip that part and just state that the answer is 9 over 2. So, yeah, we're going to leave it there. Like, I don't want to sort of waste too much time telling us how to evaluate this. It should be straightforward enough. Okay, that's that one. So that's computing an area with integration.